In this video, we're going to take a look at just rolling through a lot of examples of finding the derivatives using some of our basic derivative rules that we've talked about here in the past couple sections, past couple videos. All right, so here we want to find, in our first example, we want to find the derivative of y equals x times x squared plus 1. And we don't have a derivative rule on how to deal with multiplication of two functions, at least not at this point in time. We will soon have a rule for that. But for now, we will go ahead and use algebra. Let's just distribute that through so that x multiplied by x squared plus 1 becomes x cubed plus x. And so our derivative, y prime, we can bring the power down on the first piece, subtract 1 from the power, and then add to it the derivative of x. The derivative of x is 1. And so that is derivative for that first one. For this next problem, we have 4x cubed plus 2x plus 5 all over x. So we can, all of that's being divided by just this x. We don't have a rule for dealing with dividing functions yet. Eventually we will, but not yet. And so we can go ahead and, since it's all over just the single value of x, we can divide each one of those separate terms on top by x. So 4x cubed divided by x is 4x squared. 2x divided by x is 2. And 5 divided by x is 5 divided by x, or 5x to the negative first. So that's not a derivative yet. So when we take our derivative, we have the derivative of our first piece, the derivative of 4x squared. We have 4, bring the power down, so 4 times 2, which is 8, and subtract 1 from the power, plus the derivative of 2. That 2 is all by itself, it's a constant, not being multiplied by anything else, and so that derivative of 2 is 0. And then we have 5 times the derivative of x to the negative first. And so we have negative 5. So 5, we bring the power down, so that's 5 times negative 1 is negative 5, x to the negative 2. So 8x minus 5 over x squared is our derivative there. Excellent. For our next problem, we have 2 over the cube root of x plus 3 cosine x. So before we take our derivative, let's rewrite this. So we have x to the negative 1/3 power. So 2x to the negative 1/3 power plus 3 cosine x. And now when we take our derivative, we bring the power down, so we bring down this negative 1/3. So 2 times negative 1/3 is negative 2/3. And then we subtract 1 from the power. So negative 1/3 minus 1 is negative 4/3. And the derivative of cosine is negative sine, so we'll have 3 minus 3 sine x. That's our derivative. Here, again, before we take our derivative, let's do some rewriting of this. So this is h of x is 5 divided by 2x quantity cubed is 8x cubed on the bottom plus 3/4 sine x. And rewriting it a little bit further still, we can call that 5/8 x to the negative 2 plus 3/4 sine x. So there we're just using algebra, and now we are going to take our derivative. Looking at this piece here, we have 5/8, and we can use our power rule, so we'll bring that negative 2 down. So 5/8, if we bring that, that should not be a negative 2, that should be a negative 3. Whew, that was close. That should be a negative 3. So we bring that negative 3 down. So negative 3 times 5/8 is negative 15/8. Subtract 1 from the power. So negative 3 minus 1 is negative 4. Plus 3/4 times the derivative of sine. Derivative of sine is cosine x. That's our derivative there. If we want to find the derivative of x minus 2 times x squared plus 3x, again, we don't yet have a derivative rule for the product of two functions, so we will go ahead and FOIL this out, multiply it out. So if you FOIL that out, we'll get x cubed plus 3x squared minus 2x squared minus 6x. So that is x cubed plus x squared minus 6x. That's going through the algebra. So now to find our derivative, we take the derivative of x cubed is 3x squared. Derivative of x squared is 2x. And derivative of 6x is 6 times 1, which is just 6. Excellent. We have that derivative. We are asked to do a little bit more with this. So here we want to use the derivative to find the equation of the tangent line to the graph at this point. All right, so we have our derivative. We can evaluate our derivative at the x value here. So y prime at 1 is 3 times 1 squared plus 2 times 1 minus 6. So that is negative 1. This is our tangent line slope, specifically at 1, negative 4. And so the equation for us is going to be y minus the y value, so y minus a negative 4, which becomes y plus 4. Let's write it as y minus a negative 4. Y minus negative 4 is equal to our slope of negative 1 times x minus the x value. All right, so that's point slope form for that tangent line. If we solve that for y, we get y is equal to negative x minus 3. So either one of those is really fine. That's how we can use our derivative rules. All right, we will talk to you guys next time when we take a look at derivative rules for dealing with products and quotients. All right.